Our lunar neighbor gets a 2025 update. The moon appears deceptively close when you see it dominating our night sky. But 2025's precision laser ranging measurements reveal it sits exactly 384,472 kilometers away from us right now. This distance changes by about 3.8 centimeters every year as the moon slowly drifts away from Earth. To put this distance into perspective, you could line up 30.1 complete Earth spheres in the empty space between our planet and the moon. If you decided to walk this distance at a steady pace of 5 kilometers per hour, you would need to walk continuously for 8.7 years without stopping once. A commercial airliner flying at cruising speed would take 17 days of nonstop flight to cover this same distance. When the Apollo astronauts made this journey in 1969, their command module took 3 full days to reach lunar orbit, traveling at speeds that would cross the United States in just 12 minutes. The Artemis program has scheduled multiple lunar missions throughout 2025, with Artemis 3 planning to land the first woman and the first person of color on the lunar surface. These new missions will experience the same 2.56-second communication delay that the Apollo crews dealt with, but modern technology handles this delay very differently. While the 1970s Apollo missions relied on simple radio communications with limited bandwidth, the 2025 lunar missions will transmit high-definition video, scientific data streams, and complex telemetry information back to Earth. Mission Control can now process thousands of times more information during that same 2.56-second delay window. The upcoming Lunar Gateway Station will fundamentally change how we think about this quarter-million-mile gap. Instead of viewing the moon as a distant destination that requires a dangerous 3-day journey, the Gateway will transform Lunar Distance into a permanent bridge between Earth and deep space. Astronauts will live and work in this space between worlds, making the 384,472-kilometer distance feel more like a commute than an expedition. The Gateway's solar arrays will be visible from Earth through powerful telescopes, creating the first permanent human-made structure that we can observe in the space between planets. Recent high-resolution imagery from lunar orbit shows Earth as a brilliant blue marble suspended in the absolute blackness of space. These 2025 images capture details that were impossible to see in the 1970s photographs. You can make out individual continents, weather patterns, and even the thin blue line of our atmosphere. From lunar distance, Earth appears about 4 times larger than the moon appears to us on Earth, but it still occupies less than 1% of the visible sky. The rest is just empty space, highlighting how isolated our planet really is even within our own local cosmic neighborhood. The psychological impact of this distance becomes more significant when you consider emergency scenarios. If something goes wrong during a lunar mission, Earth cannot provide immediate assistance. A medical emergency on the moon means the astronauts must handle the situation themselves for at least the 2.56 seconds it takes for their distress signal to reach Earth, plus additional time for mission control to formulate a response, plus another 2.56 seconds for that response to travel back to the moon. In reality, this means lunar astronauts face at least 15 to 20 seconds of complete isolation during any emergency, and that assumes mission control can respond instantly with perfect information. The precision of lunar laser ranging has improved dramatically since the 1970s. Scientists now bounce laser beams off retroreflector arrays left by Apollo missions and measure the return time with accuracy measured in picoseconds. These experiments have confirmed that the moon moves away from Earth at exactly 3.78 centimeters per year, which means the lunar distance increases by about 1 millimeter every 9.6 days. Over the course of human history, the moon has moved approximately 7.5 meters further away from Earth. This might seem insignificant, but it represents measurable changes in tidal forces and the length of Earth's days. The communication delay creates interesting practical challenges for 2025 lunar operations. Real-time control of lunar rovers becomes impossible because every command takes 2.56 seconds to reach the moon, and confirmation of that command takes another 2.56 seconds to return to Earth. This 5.12-second round-trip delay means lunar rovers must operate with much more autonomous decision-making capability than Mars rovers, which face much longer communication delays. Lunar mission planners must design every procedure around this unavoidable pause in conversation between Earth and Moon. When Artemis astronauts plant their feet in lunar soil, they will be standing in a location where Earth appears as a fixed blue dot in the black sky above. Unlike Earth, where the moon rises and sets due to our planet's rotation, the moon is tidally locked to Earth. This means the same side of the moon always faces our planet, so Earth never moves across the lunar sky. From any given spot on the moon's surface, Earth either appears in a fixed position above the horizon, or it never appears at all. The Apollo landing sites were specifically chosen to keep Earth visible above the lunar horizon for communication purposes. The latest measurements confirm that this seemingly vast 384,472-kilometer distance represents our first tiny step into the cosmic scale. While this distance required humanity's most ambitious engineering projects to cross, it barely registers when compared to planetary distances within our own solar system.